New stream. I had to update that later. Oh, it did update. Okay, college algebra live stream. So it's no longer college algebra. I'll fix that later. All right. So we're moving into, I think this is what, section 2.4, right? Measures of variation. Okay. So how to find the range of a data set, how to find the variance and standard deviation, how to use the empirical rule, and I think it's Chebyshev, something like that, theorem to interpret the standard deviation, so on and so on. Let's see how much of this we can see in action. So the range of the data is going to be the difference between the max and the min. So it's going to say, if you want the range, it's going to say the max entry minus the minimum entry. That's straightforward. Find the range. What's the max value? 47. What's the minimum value?
37. Oh, yeah, 37.
So what's the range? If it's 47, is it 47 to 37?
Yeah.
What's that range? 10 what? 1,000, right? It says thousands of dollars. So 10 in this context, it means $10,000. It's okay. Okay. So deviation, variance, and standard deviation. So deviation is the difference between the data entry X and the average of the data set. So we're calculating deviation. First, we need the average of the data, the mean, and then it's just the difference between that entry and the average. So we're doing a population, from the population data set, the deviation of X is going to be X minus mu. If it's a sample data set, it's going to be X minus X bar. Same kind of deal before. Mu is a population, X bar is a sample mean. Okay. So it says a corporation hired 10 graduates. The starting salaries for each graduate are shown. Find the deviation of the starting salary. So first we need to find the what? So when we go to find the deviation, we got to say X minus the average. The average. So first we need to find the average, right? I'm kind of tired. I'm going to use this starting here. So you know how to find the average. You add up the entries and divide by the number of entries. The average in this case ends up being 41.5. So now we can go to calculate the first deviation. We're just going to say 41 minus 41.5. What result do we get? Could be a negative 0.5. So I think that means it's to the left of the mean. Is that right? 38, the X minus X bar, or X minus mu, negative 3.5, so on and so on. Any questions here for the deviation? Okay. My water. So then population variance. So first we find the deviation, right? X minus the mean. Then each deviation, we're going to square the deviation divided by the total number of entries. So it's a sum of the squares. That's what the SSX, sum of the squares. So population variance, population standard deviation. So once we have the variance to get the standard deviation, we just take the square root of the variance. Any questions there? We will be doing open notes. You just need to know how to use these formulas. You don't have to commit these to memory. You just need to know how to use them. Okay. So all this is saying, like this first one for the variance, you take each entry. First, you got to find your mu, which is the what? What is mu? The mean, which is our average, right? Average. We got to find the average of the data. So then we got to say X minus the average for each entry. That'll give us the variance, I think it's called. No, deviation. That'll give us the deviation, X minus the average for each entry. Then we square the deviation and divide by the number of entries. That's going to give us the variance. It's called sigma. Sigma squared. That's symbol, sigma squared. Sum of the squares, okay? So now once we have the variance to get the standard deviation, we just take the square root. Okay, let's see it in action. So find the average of the data, of the entire data. Find the deviation, so we're going to say x minus the average for each entry. Square the deviation, add up those squares. All right? This is what we're going to be doing. Then we're going to divide the sum of the squares by n. That's going to give us the variance, and then we take the square root to get the standard deviation. It's okay? Let's see it in action. So we have this data. It says find the variance, the standard deviation, find the variance and the standard deviation of this data. It tells us that the mu is this. So we might have our, I think we said the classes. Let me see. Maybe it's for each data instead of classes. So we have each data. You see the data listed. We have the deviation of each data, x minus the average in the second column. Then we square those results so that negative 0.5 squared becomes a positive 0.25, so on and so on. It's okay? So we squared all those data entries. Whew. All right, let's keep going. So then we squared all those data entries. If we add them up, we get the 88.5. Divided by the total number of entries is the 10. That's where the 8.9 comes from. So the variance in this case is going to be 8.9. Then the standard deviation, we take the square root of that, which is approximately 3 in this case. Okay? We need to work with it.
Why is it $3,000?
Oh, because the original chart is in thousands of dollars. So 3 in this context means 3,000. Okay. And that was that population variance? There was population variance and population standard deviation. Now we do sample variance. It's still x minus the average. The sum of the squares. But now the sample variance we're going to say is going to be divided by n minus 1. And then the standard deviation, once we calculate the variance, you just take the square root. So it's the same, but except for that denominator is now going to be n minus 1. I'm not sure why we do that. I can't think of the reason why. But that's just how you calculate it. So again, something like this, you just need to know how to use it. I'm okay giving you this formula. This okay? Okay. We're actually moving along fairly well. Okay, it's past my bedtime, by the way. Oh yeah, no, it does that whenever I stream. It says that that's the time, and it's just. But as soon as I unplug it, it goes back to normal. So I don't know what's the deal with that. All right, so this is the same kind of setup as the last one. We're going to find the average. We're going to find the deviation for each entry, so x minus x bar. We're going to find the sum of the squares of those entries. So those deviations we're going to square them. Then we're going to add them up. Then, since we're finding a sample variance, we're going to divide by n minus 1 instead of divided by n. And then that's going to give us the sample variance, and then standard deviation, and the square root of that result. All right, let's see it. Find the sample standard deviation and the starting salary. You think you can do this with only the headers? Just for the sake of time, I'm going to use what's already here. If I wasn't rushed for time, I would have you do it. All you would do, you would list the data. You would go ahead and calculate the average. You would find a deviation for each entry, so x minus the average. You would square those results, each of those results. You add up those squares. Since we're trying to find a sample variance, then we're going to say divided by n minus 1. That'll be the sample variance right there at that point, I think, right? And then we square root that result, and that'll be the sample standard deviation. And that's what this chart is essentially doing. Each entry, deviation, squaring those deviations, and then the sum of the squares divided by n minus 1, we get 9.8. That's the sample variance. Standard deviation, you square root that, you get 3.1. You might want to, What's a good idea is take the original and maybe create a blank chart with those entries, salary, the deviation, and the squares, and then make sure that you can arrive to the same conclusion doing it by hand. I know I'm kind of glossing over it a little bit, and I'm just using my slides. You just want to confirm and make sure that you can get these results. All right, let's see. Let's see. Whew, I gotta stand up. I'm fading. Oh. Yeah, I'm usually I wake up every day about like 3:30, 3:33. Every time I wake up, it's right on the money. I'm like, man. So, I usually go ahead and get up and I'll do work and be on the sticks a lot of times, playing games a lot of times. But I'll make sure to get my work done before. Then I'll go back to sleep. Then it's like time to get up as soon as I go to sleep. So that's why I get sleepy by the time I get to you all. So now, we have the sample office rental rates in dollars per square foot for Miami Central Business District shown in the table. So we have some rental rates. It says use a calculator or a computer to find the mean rental rate, the sample standard deviation, so on and so on. Okay. Now, a lot of these devices can crunch these and just spit this data out in an instant. You don't even have to create tables. You do have to have a copy of the data, but then once you have the data, a lot of this stuff, it'll find the standard deviation. It'll find the, all the things, variance and all that kind of stuff. So okay, now here. So this walks us how to calculate these. Say if we were, let me see. I'm just not going to do it right now. I want to show you on the TI 83, 84 plus. I'll let you look that up on how to find all these. You just do a quick Google search and it'll walk you through how to calculate the mean at the 33, or the sum of the squares, standard deviation. So it'll walk you through how to do this in a graphic calculator. So if you got on an exam, if you know how to do it, that's fine. Okay. All right, I'm going to keep moving. So as soon as I finish this section, we'll call it a day. Because I'm thinking. Standard deviation. Okay. So standard deviation is a measure of the typical amount an entry deviates from the average. Right? The more the entries are spread out, the greater the standard deviation. For instance, in this example on the far left, the average is 5, and the standard deviation is 0 because the data is not spread out. It's all congregated into one section. All right? Yeah. So then in the next one, the average is 5. But now the standard deviation here is 1.2. So notice it's a little bit more spread out. It's still, it still kind of centers, bunches up around the center, but it's spread out more so than the last one. This one, the average is 5, but notice the data is very spread out, so that it has a higher standard deviation. So the standard deviation is telling us how the data is moving away from the center. The higher the standard deviation, the more spread out the data is. The lower the standard deviation, the less spread out the data is. Okay. I have another chart that's I think it'll kind of drive home the idea home a little bit better. So let me just give me a minute to get to it, and then we'll get to it. I'll bring it to your attention. For data with a symmetric bell-shaped distribution, the standard deviation has the following characteristics. It says about 68% of the data lie within one standard deviation of the average, 95% of the data lie within 2 standard deviations of the average, and 99.7% of the data lie within 3 standard deviations of the average. Is this okay? I'd rather see this in action. So one standard deviation has a width. It's 68% with one standard deviation. Okay, you see the average in the center. You see x bar plus one standard deviation, and then you see x bar minus one standard deviation going to the left. Okay. So what and so what? Okay, we're in the home stretch. We got about 15 slides or so. So in a survey conducted by the National Center for Health Statistics, the sample average height of women in the U.S. ages 20 to 29 was 64.3 inches, with a sample standard deviation of 2.62 inches. Estimate the percent of women whose heights are between 59.06 and 24.3. So now, what's the average here in this case? What's the mean? Give me a color. No, other than me. A Okay, I think pink is, yeah. Okay, so it says, what's the average? What's the average? 64.3, right? It says the average height. So the average height is 64.3 inches. It says standard deviation. So now, what's 64.3 plus 2.62?
No, 66.9.
Okay. Hey Siri, what's 64.3 plus 2.62?
64.3 plus 2.62 is 66.92.
So this is sample. So I think this is like our X bar. This is X bar plus one standard deviation. Let me see how they, yeah. Hey Siri, what's 64.3 minus 2.62?
64.3 minus 2 is 62.3.
Hey Siri, what's 64.3 minus 2.62?
64.3 minus 2.62 is 61.68.
Okay. That's one standard deviation. Let's do two. Hey Siri, what's 66.92? Hey Siri, what's 66.92 plus 2.62?
66.92 plus 2.62 is 69.54.
69.54. Hey Siri, what's 61.68 minus 2.62? This zero. Hey Siri.
2.62 is 58.98.
Hey Siri. Hey Siri. What's 61.68 minus 2.62?
61.68 minus 2.62 is 59.06.
59.06. This is our X bar. It's supposed to be an S, one standard deviation. This is two standard deviations. All right, let's see if we can do this now. It says estimate the percentage of women, and that what we said that first standard deviation was what percent? Was it 17%? 34?
Yeah.
34%. So it's 34% here, right? 34% here. Then 13.5, is that right? So this one is 13.5%. This is also 13.5%. 2.35 is that last part. So this over here should be 2.35. 2.35. Let me see. I think I'm doing it right. It says estimate the percent of women whose heights are between 59.06, which you see it on the far left, and the 64.3. So now that we fill in those percentages, what percent is between the 59.06 and the 64.3? 34 plus the 13.5. 34, 44, 47.5. Is that okay? Nearly 50%. Let's see. So now they have theirs. You see the same kind of deal. We just didn't do the graph. 47.5. Okay? Is that okay? Any other questions, comments, or concerns? I think it's Chebyshev's theorem. So it says the portion of any data set lying within k standard deviations of the mean is at least 1 minus 1 over k squared. So when k is 2, in any data set, at least 1 minus 1 over 2 squared equals 34. 75% of the data lie within 2 standard deviations of the mean. 75%, it's saying that 75% of the data lie within 1 standard deviation. 89% lie within 2 standard deviations. Sorry, back up. So again, 75% lie within 2 standard deviation, 88.9% lie within 3 standard deviations. Is this okay? Is this okay? Okay. Time. Okay. We're almost there. So the age distribution for Florida are shown. Apply the theorem to the data. What can we conclude? So we have our average and we have the standard deviation. Okay, let's just see if we can do it kind of quickly. I need a little bit of space. I'll go here. The mu is, so mu, 39.2, right? Standard deviation is 24.8. Age distribution. Let's see. I'm going to look at something. So we have our mu. Let's k equal to 2. Oh. So apply Chebyshev theorem to the data using k equals 2. What can we conclude? So then you see when k is 2, we're going to say mu minus 2 sigma. That's going to be mu was given to us minus 2 times sigma was also given to us. So then we get this negative 10.4. It says I use 0 since age can't be negative. What is this telling me? So if we start at the average and we move left of the average by 2 standard deviations, we get negative 10.4. I think if we take the average and move to the right by 2 standard deviations, we get 88.8. I think so. If we said 88.75, yeah. So we're going to use 0 because ages can't be negative. Let me see. What can we conclude? I think if we actually draw that bell-shaped curve, it'll help a lot. Population, so then the age, the number of people, and then the ages are at the bottom. Okay, let me kind of finish that chart and see if that helps. So 1 standard deviation we said was what? 24.8. So I'm gonna say I'm just gonna put 1s. Hey Siri, what's 39.2 plus 24.8?
39.2 plus 24.8 is 64.
Hey Siri, what's that answer plus 24.8?
64 plus 24.8 is 88.8.
Okay. And then if we go to the left by 2 standard deviations, here's going to be 1 standard deviation. Here's going to be the second. Hey Siri, what's 39.2 minus 24.8?
39.2 minus 24 is 15.2.
Hey Siri, what's 39.2 minus 24.8?
39.2 minus 24.8 is 14.4.
Hey Siri, what's the answer minus 24.8?
14.4 minus 24.8 is negative 10.4.
I'm going to force it to 0. All right. So we go left by 2, we get the negative 10.4, but we just went on to force it to 0 because it doesn't make sense to have a negative age. And then going to the right, we got the 88.8. Oh, okay. It says the age distribution for the shown apply Chebyshev's theorem. So it's going to be 1 minus 1 over k squared. K in this case is what, 2, right? So you see the theorem? When k is 2, it says 75% of the data lie within 2 standard deviations of the mean. So then if we apply it, we're going to get 75% of the population is between 0 and 8 years old, 88.8. Is that okay now? So the theorem, again, they gave us the k they wanted to start with. We plugged in that, and it's telling us something about how the population behaves. When it's 2, we got the 75%. That's the 75% of the data lie within 2 standard deviations. In 3, we get 88.9% lie within 3 standard deviations. That's okay? Okay. All right, I'm going to move forward. Okay, so this is the sample standard deviation for a frequency distribution. Because remember when we did the sample frequency distribution, we had the sample standard deviation, I think it was. We had to divide by n minus 1, right?
Mm-hmm.
Yeah, number of frequencies. Okay, let's keep going. So again, something like this, you just need to know how to use it. I'll let you use your notes. You just need to know how to use these kind of formulas. You don't have to commit this manually, you just need to know how to use it. Put a freeze. Keep on. Uh-oh. Are we frozen? No, I mean, like my screen. That's still running. It says that it's healthy. Not that much of a delay, is it? Let's see. Okay, I guess it is just kind of a delay. So it seems like it's healthy. It's a delay. All right, so we have this data of children, the number of children per household in the region. Find the average and the sample standard deviation. Let me see, 35. You can walk through that. We'll come right back to this. Now, I mean, this is just essentially the same. I'm okay. Like if you have a blank table, you have your x's, you have the frequency of each x, you have x minus x bar squared. Then we say times the frequency of each one, and then we say divided by total number of entries. What's an n in this case? How many entries?
So X bar is basically the same as me.
Wait. How many entries are here? X bar is the same as me, yeah. How many entries? How many zeros do we have? 10. How many ones do we have? So how many entries do we have? What do we do with those numbers? We're going to add up which numbers? Column 1 or column 2? Are we going to add up the entries in column 1 or column 2? Let's see. So 1, so those are the number of children in each household, but then if we're trying to find out how many people were surveyed, see on the left are the ages. So the 0, I think that's right, 0, 1, those are the ages, right? Then the 10 means that we had 10 that happened 10 times. The 19 means that that one happened 19 times, right? So we have 10 plus 19, that should add up to 50. Is that right?
Yeah, okay.
Okay. All right. So give that some practice. I'm going to leave the rest of this as an exercise. Let's see. But the best way to do this, in my opinion, just take a blank chart, but you just want that header, and then follow each header. Okay? So find the sample standard deviation. Okay. So it's just a formula. I would say just use the formula. Okay, it's gonna take practice though, because it's not so trivial. It's not so obvious. The coefficient of variation. It describes the standard deviation of the data set as a percent of the mean. Coefficient of variation is going to be sigma over mu times 100%. And if it's a sample data set, it's going to be the standard deviation over x bar times 100. Let's see. So we have this table. It says find the coefficient of variation for the height and the weight. So I think that we essentially do the same thing where we're finding the variance, the deviation, the variance, and the standard deviation. We still do that whole thing, and then we use this to take it a step further. I think this was going on. So notice we have the average. The standard deviation was 3.3. I think that was given to us. Maybe we can calculate that. So sigma sigma squared. That's the standard deviation, right? Yeah. So we would have to finish out that chart like we did last time, where we have the entries. Let me see. Entries, the same chart that we used last time. I'm just kind of feeling this again, right? But it's essentially the same as before. Mu is the average. The standard deviation is there. So then the coefficient of the variation. Once we have our mu and our standard deviation, we can find the coefficient of variation for this context. So it's going to be sigma over mu times 100 to get to 4.5%. Let's look at another one. The average weight is this, with the standard deviation of 17, the coefficient of variation of the weight, sigma over mu, same kind of deal. I'm trying to see if there's a difference between the two. Okay. So that's enough for one day. Let me go ahead and share. So let me share. I'll send it to box. This is the 2 p.m. Send it. So now, when that bar loads, you'll have a copy of everything that the second half, I think I loaded the first. If anything is missing, just bring it to my attention. But you now should have a copy of anything that you saw on the board. We're going to pause for the cause. Are there any questions, comments, or concerns before we dismiss? So let's be ready for exam 1 this upcoming Wednesday. The study guide is at least loaded on Moodle. Make sure that the PDF is there. There should be a PDF loaded on MyMathLab. On Moodle as well. The study guide is loaded on MyMathLab. Check Moodle for the PDF, a PDF version of the same study guide. Okay. You just want to have your homework notebook ready to go, neat, organized, where you can kind of quickly find questions with the original questions with the supporting work. I can't think of any other announcements. Any other questions, comments, or concerns? Go ahead. Just chapter 1, right? Is that what we said before?
Yes.
Yeah, just chapter 1. For exam 1, chapter 1. Okay? All right, if there aren't any other questions from one beautiful mind to another, enjoy the rest of the weekend.